Welcome everyone to the Macquarie University webinar today. Today we have with us Professor Hume Winzar from the Macquarie Business School. My name is Rita and I'm a Macquarie alumna. I studied a Bachelor of Commerce at Macquarie University and I'm also an international student from Vietnam previously. We're very happy to have you all here today. So all of you must have already been holding a full offer or a conditional offer for our Business Analytics program at Macquarie University in Sydney, Australia. So for today, we have our professor here to talk you through the program structure of the analytics program, what career outcome you should be expecting from the program, what skill set that the program will be teaching you, and also at the end of this webinar, you should also be having a chance to ask some quick questions that we will be able to take and answer to help you through your journey to choosing your degree at Macquarie University. I guess I'll pass it on to Hume now because I wanted to just quickly introduce who you are and what you teach at Macquarie University.
Thank you, Rita, and welcome. I've arrived in the analytics area from a route that's different from many, in that my background has actually been in applied economics and in psychology. So I've been in a marketing department for a long time. I just happen to have also had an interest in analytics and statistics and data visualization, and that's what brought me to this relatively new area of business analytics. And you'll find that most people in business analytics at the moment have come to that program or to that discipline through quite different routes, some from engineering, some from statistics, some from computer science, and some from economics or even actuarial studies. So it's a mixture of different skills. In fact, you'd regard it really as a skill set rather than a specific discipline. It's one of the things which I find really attractive about the discipline, because it can be applied in so many different areas of organisations and government and any human enterprise. It's a very, very exciting area.
Thank you so much, and that's really nice to have you with us here today. And I think a lot of our students here today also coming from different backgrounds and coming to the degree with maybe non-technical knowledge or different knowledge bases around different areas of different industries. So if you could define business analytics in a very short definition, how would you say it, and how would you explain what it is in its whole definition?
I agree. It's sometimes difficult to separate business analytics specifically from, say, statistics or from computer science or from many other things. And the reason is that it embraces all of those sorts of traditional disciplines. What brings them together is that you need to combine data gathering, statistical analysis, modelling, so that we can understand the processes that are going on, and then make predictions about what is going to happen next, and then be able to communicate those results that you have to decision makers or other managers or the public generally in a way which is easily understood for those people who haven't gone through that kind of analytical process or who don't have the same skills that you do. So that you really need to combine all of these different sorts of skills and understand the context in which the decisions are being made, so that you can make sound recommendations based on the evidence which is available.
I guess it sounds to me that so when you do this degree, you'll be studying data gathering techniques, you'll be studying stat analysis skills, you'll be studying modelling skills, how to make predictions, and how to communicate those outcomes as well. Why are those skills in such a demand right now in the industry?
They're in such demand. Well, there are some areas where we've got sufficient, statistics and data gathering, got lots of that. In fact, we've got too much data for most organisations. Yeah. The problem is bringing it all together and making sound decisions. So it's the modelling part, and it's the prediction part, and it's the communication part. And that's where just doing, say, a straight computer science degree is different, or just doing a straight economics degree or a straight management degree is different, because we're bringing these together so that if we understand the context and we understand the analytical skills, then we can communicate better. So what we're trying to do is give people sufficient skills that they can apply the right kinds of analysis,
yep,
and then explain to people what's going on.
Yep. Same. So within the course structure for business analytics at Macquarie University, how do students acquire those skills over their course duration, program duration?
Well, okay, this is where perhaps it's worthwhile separating undergraduate program and the postgraduate program. Because if you come into the undergraduate program, then we've effectively got a marriage between the business school and the science faculty, whereby we're teaching the core skills for running and managing a business. So that would, that's accounting, economics, management, a bit of statistics, some marketing. And then we've got the science
program.
Yeah.
Oh, wait, no.
And then the science program, which is a bit of computer science, yep, a bit of programming. And then by second and third year, we're dealing with business analytics, so predictive modelling, okay, and yep, clustering and so forth.
Yep.
Now, the postgraduate program, we assume that you've already got a degree in something science-based or computer science-based, or you have some skills in management, accounting, yep, finance, management, marketing, yes, whatever. So science-based people will be asking you to do a little bit of catch-up, yep, with the management and marketing and accounting. Yep. Those people have already got those skills, yep, will be asking you to do some catch-up with some data science and statistics.
Yes.
By that point, you've got similar skills.
Yes.
Or at least compatible skills, yes, so that you can communicate with each other using the same language.
Yep.
And then we get into the fun stuff where we play with predictive analytics and, yep, machine learning techniques and data visualization and the cool stuff.
That's awesome. So what I'm hearing is that basically for the bachelor students, they'll be going through both the business stream of units, so that's management and accounting, and they also have to go through the stream of science, so like coding, computer science in the first after the second year.
That's correct.
And from that point on, they definitely have gained that basic knowledge in business and in science. They start going into the business analytics specialization units.
Yeah.
And that's from the second year onwards, you're saying? And then for the postgraduate students, depends on what background the students come into the program from. Mm. If they have done their business undergraduate degree, they'll be asked to catch up on some foundation computer science units. And if they come from their computer science background, then they have to be taught some business foundation unit on the same level. So you mentioned some cool stuff about data science, AI, machine learning. So can you elaborate on that a bit more?
Well,
so when did they get to the end of the degree? So when did they get to play with the fun stuff?
Well, much of it is fun. But the bit that I regard as
fun,
the really cool
fun,
stuff,
yep,
is when you take a large amount of data and you find trends, and we'll find this little nugget which says, here, this is what's causing a change. Yep. That's the bit which is
real fun.
Yeah. Yep. And then also being able to, visualise it. So, we spend a great deal of time learning to communicate, not just in writing and making presentations and so forth, but we learn to have pretty good skills with software such as Tableau or Power BI. Postgraduate students will become quite skilled at both of those. Undergraduate skills, mostly it's Tableau because the market seems to want that so much more. And with those two things, if you go online and do and ask for a demo video, you'll see that you can do some pretty cool stuff. Well, we do that, definitely.
in their degrees at Macquarie University.
Absolutely.
It's that in their final year they have to play a practical project where they get given real data from a real university partner, and they have to actually give outcome based on that data. And how do you get, how do you get that project working?
Well, okay. What in the final semester,
Yep.
for most people, it's the final semester.
Yep.
Both undergraduate and postgraduate, we have a client, and students act as effectively consultants, and we, in some cases, go out into the field, but classes are large enough now that that's not really feasible. So the client comes to us and presents the problem and explains, this is the nature of the problem. Here's some data that we have that relates to the problem. And at that point, student teams start asking questions and exploring the data, then come back to the client maybe a couple of weeks later to say, this is what we've done so far. This is some questions that we need to have clarification on. And that process goes on for maybe 10 weeks. And then we write a report and present to the client. Now, thus far, it's
so fun.
It is, and many of the students tell me, you always tell me afterwards that it was pretty scary because because the client is there usually with several other executives,
yes,
and possibly some people who've been recruited,
yep, as
graduate students,
yes,
and they're all there. And they look as if they're passing judgment.
Yes.
And so you feel as if you
have to present your work and your outcomes to these senior people who's like, what are they going to say to my work? Is it going to be a good outcome, a bad outcome? And is it right? Is it wrong? You never know. It's a real business problem as well.
It's a very real
yes,
problem. In fact, well, the one that our students have just presented, these are undergraduate students who presented to a very large transport company. This is a company that manages railways across Australia.
Wow.
And they were dealing with accidents, things that involve the train going across an intersection when it shouldn't have, things like that. And these are very, very dangerous. People could lose their lives at the very least. Trains can become derailed, which can cost many, many thousands of dollars because tracks have to be repaired. Trains get delayed. They might miss the ship that they're taking cargo to. It's a big deal.
Yes.
And so students had data about each of these accidents, which they were able to put onto a map so that anybody could click on a particular incident and get summary information.
Yes.
Using Tableau. And then they did some further analysis and found that there was indeed a relationship between the kind of accident and the skill set of the drivers of the train.
Wow. Yep.
Now, this was new information for the client, and it led to what it has led to, because this is what the client told us immediately after the students made their presentations, that we've got several things that we need to do as a result of your analysis.
Wow.
So very applied, very important and valuable information that students were able to extract from very, very complicated and messy data. So that was the most recent one. I can tell you about last year's as well, which is also fun.
We want to hear it. Yes, please. Yes.
Well, it was a telecommunications company, also a very, very large one.
And a different real business problem.
Another real business problem. Students were given, I think it was about 80,000 telephone subscribers information.
Okay. Anonymised though, right?
All anonymised.
Yes.
Yeah.
Because data privacy here at Macquarie University. Absolutely, yes.
And summary information about numbers of phone calls made, amount of data downloaded, text messages, what kind of contract they were on, whether it was the telephone, the handset was a bring your own, or whether it was part of a subscription. All of that kind of information. And the question was...
My number was on that list. Wasn't on that list.
There were about 60 separate variables.
Wow.
There.
Massive data set.
Huge data set, a large number of cases. And And the question was, can we find any kind of pattern which indicates whether or not a person is likely to churn? That means quit their account with this company and go to a competitor's company. And with that, students found, there were indeed patterns in the data, and they were able to make some recommendations about what to do about that. Again, real data, real organisation with a real problem, and students came up with some extraordinarily detailed information, and what I felt most proud about was seriously the executive that we'd been dealing with up until then had brought with him 2 other executives, right? Plus 5 people who had just been recruited as graduates
at that telecommunications company
from another university. Most of them were from another university except for one, including people who had degrees in computer science and statistics and so forth. And he gave them a big nudge and said, "Do you guys feel threatened? You should."
Yes, it's only students and they're doing that. And you're working with us. And
these were undergraduate students who were doing this. And I felt so proud.
Oh my God, that's awesome.
Because the standards are really good. Now, I mean, okay, they've been so far relatively small classes, and there's something pretty...
What would you say small? Small, like 20, 30?
This was a class of, less than 20 people. This last year we've had, I think 40 people will graduate. Next year will be 120 who will graduate. And the year after that will be 300 and something at undergraduate level. At postgraduate level we're expecting maybe 60, and then more than that as we go.
Wow. And I would say this is honestly really great exposure for these students to be working on these real business problems at just a university level to these real large companies. And when you mentioned like this like massive data set with like 60, 80,000 rows, what tool or what software did you teach your students to analyze? You mentioned Tableau, you mentioned Power BI. Was anything else? Was there any coding language involved?
Well, yes. First, you're not going to graduate without having superior skills with spreadsheets, Excel, that kind of thing.
Good old Excel.
I know.
They're powerful.
We give it a hard time, but it's the sort of tool that everybody will have on his or her desk. So
you have to master it.
Yes, you should be able to do things. If you're just doing quick one-off kinds of analysis, then Excel is as often as not the one to use.
Yes.
We also use statistical programming languages such as Python and R, and because again that's the industry standard, we'll be moving to potentially other statistical programming languages as the need comes about. Also, we also expose people to AWS or Amazon Web Services, right? Studio, SPSS, Modeler. Those are useful tools for doing more detailed analyses, or combination of one-off and things which are going to be pipeline sorts of tools. And also some of the most recent tools that don't require very much in the way of programming at all, such as Rapid Miner. And those are extraordinarily powerful tools as well. Depending on your skill set, the direction that you want to take, then you can focus on those as you need. You won't escape without learning some Python and some R.
Okay. That's
but you'll have the option. In fact, we actually made a very, very conscious decision, because we spoke to people at SPSS, we spoke to people at SAS, and we spoke to people at Data Robot and a couple of other big companies that deal with data, and they wanted to tie us down to their particular software. And this is where it really became a dilemma, because they were offering us not
to teach their program.
Well, discounts for the university,
yes,
because the university pays a lot of money to get access to these sorts of tools.
So students could use it for free throughout their studies.
Yeah.
Yes, and as alumni as well. Yes.
Well, that's right.
Yes.
But it means that all of our graduates are, learn only one technology.
Yeah,
and we made a very conscious decision that we wanted to be technology agnostic.
Yes.
So that we quite deliberately expose you to some of the core technologies, and that's
yes.
Python and R,
yep.
and some of the point and click and cloud-based technologies such as SPSS Modeler and AWS Studio, and some of the others that are around as well. So that you can tell a potential employer, I've had exposure to this, and this, and I understand how they all work.
And then you never know what the company you're going to work for, what are they going to use. So the more technology or the more skill set the students have, the more companies they can actually get jobs for, because then they could just say, hey, I know these 5 different, I know Tableau, I know Power BI, I know Python, I know R, I could do any of these if you're at the employer company, because you don't know what they're going to be using.
No, you don't know what they're going to use, and you don't know what's going to be the next thing to come online.
Yes.
Very quickly, Python is likely to be overtaken by another programming language called Julia, which is, have you come across it?
I've never heard of Julia.
No, there you go.
Yes.
But it's rapidly gaining credibility because it has the same kind of relatively easy learning curve, and yet it's like hundreds of times faster.
Oh, wow, yeah.
So, that's the thing that's going to be used next.
Yes.
And if you've got some basic skills with one programming language, then it's relatively easy for you to learn the next one. Similarly, if you've got some skills with one of the streaming modeling techniques that you'll come across with, say, AWS Studio or RapidMiner, or SPSS Modeler for that matter, then you're easily able to adapt to any of the other sorts of technologies. So you have sufficient skills that you can move into pretty much any technological environment.
Any new things that come up as the next big thing in technology world, we don't know that. So how often in the degree do they get exposed to these practical demonstrations? On a weekly? Oh, wow. On a weekly basis, will you say how often they have to be on a computer, like trying to do something coding related or some analysis related? How often would that happen?
You could expect every semester you'll be doing at least one unit that requires you to be doing some kind of coding.
Wow. That's very, very frequent.
Yeah. Now, okay, it's not coding to the extent that a computer science major would be doing, but you learn some basic skills.
Yes.
So that as your career or as your interests or as your opportunities develop, you'll have the skills to learn those as you go. Because we have to be, honest, in the space of 3 years for an undergraduate program or 2 years for a postgraduate program, you're not going to be an expert.
Yes.
But you'll have the skills to get your job and be productive immediately.
Yes.
And be able to learn. And that's probably another thing which differentiates us so much more, in that we focus on the learning as you go and learning as you need and anticipating what are the next things that we have to learn. So, I mean, I joke and say, work it out for yourself, but
people need to know.
But
they need a nudge.
But yeah, if we create an environment where we encourage people, here, try doing this, and then you see all the aha moments happening at different points in the semester, and you realise, now they're getting it, and now they're answering the questions for themselves and looking it up and helping each other. I guess that's another aspect which differentiates probably the culture at Macquarie that compared with some of the other universities that I've worked with. Yeah. And that is, there genuinely seems to be a culture where people, give each other a hand, because you learn more by actually sharing with other people. Yes. It's remarkable, isn't it?
Yes, it's remarkable. And I've experienced it myself. I studied here for 3 years. So in terms, I think you've touched on a bit, and I feel like a lot of our students right now actually have offers from multiple universities with the same degree. And you said that Macquarie is probably stand out for is helpful, community-oriented culture. We're very focused on making sure the students are ready for the next big thing in the future. What would you say are some of the other key differentiators with our business analytics degree at Macquarie University that will make us really different from other universities?
Well, specifically in the business analytics program, probably that, well, a couple of things. One, we spoke extensively to employers ahead of time.
Yes.
We developed the undergraduate degree program entirely in consultation with industry, because we wanted to understand what it is that they needed from a graduate. And several times potential employers told us words to the effect, I want to be able to give some young graduate some data and say, here, answer this question.
Oh, wow.
I want them to come back a day or two later and say, I answered the question as you gave it to me, but I interrogated it a little bit further and I found this little piece of information. Does that help at all?
Wow. Yeah.
You know, and it's that difference.
Yes.
That
little bit of extra that I can find for you in that data set.
Yeah.
Yes.
And in order to do that, you need to have the ability to not just answer the question, but also understand the context in which the question is being asked.
Yeah.
And the organisation that is asking the question, so that you can pull out those pieces that could be of use.
Yes, and that's the key thing.
So that's what we were focusing on.
Yeah.
Now, we did very much the same thing with the postgraduate program. We spoke to industry, but we also had a very, very strong look at all of the other postgraduate programs there are in business analytics. And in Australia, I think there are 6 at least. Now, and we also looked at some of the big programs in North America and also in France and England. We didn't look at the German ones because my German is terrible. I'm sorry, but there were a couple there anyway. But we had a look at their programs as well, and it struck us when we were workshopping, you know, how to structure the program, that there were some programs that were run out of business schools, and essentially they were taking people who had a data science degree and teaching them some business. So it was really a rejigged MBA is what they were doing.
Yep.
And then there were other programs that run out of a science program for people who had some business background. And
they poured it into it.
And they were doing, and they're giving them a crash course in computer science.
Yes.
And
in analytics or in stats. And yep.
So, and then said, there you go, you're now a business analyst. And it was, you know, and we said, no, we're missing the point.
Yes.
All of them are missing the point. What we want is somebody who is able to understand the problem in context, so that we're able to, you know, take a real business problem and ask the appropriate questions.
That's right.
And come up with appropriate solutions.
That's right.
Because frequently you don't need to have really, really clever analyses in order to answer a problem.
Yep.
And quite often, a quick answer that's about right is as important or more important than a perfect answer sometime next week.
That takes longer. Yes.
So, you know, if you understand that kind of environment and you understand the context once more, as well as having the skills, then you're going to be a useful person within an organisation.
Business analyst. Awesome. So I guess now that we've touched on like all the course structure, what they're going to be studying, what technical skills they're going to get, what are the career outcomes that the graduate can expect from this program?
Pretty good, I'd say. Well, I can tell you that, we've had only about 100 of our graduates from the business analytics program, undergraduate program, graduate so far. Every one of them had received employment offers
awesome.
Before they graduated.
Before they even graduated.
Before they graduated, yeah.
Yeah.
So, you know, we've got 42 who are graduating in the next couple of weeks.
Oh, yes.
and all of them are either currently working in business analytics or have been offered jobs in business analytics. Now, 2/3 of those are domestic students, 1/3 are international students. All of them also have jobs. We think there's 2 from Vietnam, for example, who are working as interns for 2 different organisations because they will be going. They've decided they're going home in next February, but they're working full time from this week, I think, and getting paid full time wages for the next 2.5 months.
That is awesome.
And the same applies to, we've got 2 students from Taiwan, 1 from China, 3 from Indonesia, all of whom are working right now.
That is awesome. And what are some of the employers they're working for? Some of the employers they can be looking at for jobs.
Well, it's mostly banks and consulting firms. They're the ones who have the greatest need and who can afford to pay a little bit extra, and who are willing to pay to train people. So that's probably, I don't know, maybe 1/3 are working for financial organisations of some sort. Others are working for consulting organisations such as the Big Four.
Like Deloitte, EY, KPMG, PwC.
That's right.
Big banks like Westpac, St. George, National Australia Bank will be looking for these graduates to go to their businesses to start making impact and creating business insight.
But also telecoms.
Yes.
There are 2 really big telecom companies in Australia. That's Telstra and Optus. Our graduates are working there as well. And of course, some other big companies, beverages, the Coca-Colas and Schweppes and those sorts of things. They're all working for them as well.
Wow, that's awesome. And in terms of, so if they get a job after their graduation, what sort of potential salary range are they looking at, both also for undergraduate and also for postgraduate? For them, that can be different.
Yeah, they can be hugely different, and the range is really wide. And it depends on the kind of organisation that you work with, and the skill set that you arrive with. It also depends somewhat on your personality, your character, your communication skills, and occasionally just dumb luck. But an undergraduate should expect to start $65,000-$70,000.
So was that $55,000-$70,000?
$65,000 to $70,000.
Wow. Yep.
And
65 per year, though, right?
Yes, per year.
Yes.
And postgraduates probably, $75,000 to $90,000.
So beyond undergraduate salary range. Yep, that is something that people should be looking at as potential salary ranges when they apply for jobs or looking at their career outcomes options.
But once again, we don't command the employment market. It's it's a function of many different factors. And if you find yourself with not a high paying job, right, don't blame us. It's you.
No blame the degree. We've done all that we can to help you. Hume, thank you so much for all that you have told us today about the degree at Macquarie University. If I could ask you for one last question, so what advice would you have for our potential students coming to Macquarie University? What would you say to them?
You're enrolling in this program, and both undergraduate and postgraduate, they're relatively new disciplines. You're enrolling in a program like this, whether it's here or somewhere else, because it's new, because it's it's innovative. It's something that's big, and you can see it happening in the future. That obviously means that you can see into the future, and you've got some enthusiasm for it. Maintain that enthusiasm. Be enthusiastic. Be curious. Ask questions. If something you find interesting sparks joy, then explore it some further. And become skilled at it. Share it with other people, share it with your professor, and see if you can turn it into something which is a unique thing about you, that you become a specialist in some very, very small area, and you'll find that doors become open for you. That level of enthusiasm and specialisation, and you'll have a great fun time.
That is amazing advice. Thank you so much, Hume. We'll be taking a quick break now, and after the quick break, we'll be inviting one of our current students in the Business Analytics program to come here, so we'll start taking questions from everyone. We'll see you in a bit.